Good morning, everybody. Today we have to continue the explanation of chapter 13 about alkanes. In this video, we are going to explain the following objectives: isomers and physical properties of alkanes. First, let's start by defining isomers. Isomers are different compounds that have the same molecular formula but different structural formula. Let's take the following example. C4H10, it's a molecular formula. In this compound, we have 4 carbon atoms and 10 hydrogen atoms. The first way to represent C4H10 is by drawing a straight chain alkane. In this case, the name of this alkane is butane, since it's a linear chain made up from 4 carbon atoms. The second way to represent C4H10 is by drawing it as a branched chain alkane. Look at the internal carbon atom here. It's bonded to 3 carbon atoms. It's a branched alkane. Okay? To draw a branched chain alkane, simply remove the terminal carbon atom and attach it to the internal carbon atom. What's the name of this hydrocarbon? It's a main chain here made up from 3 carbon atoms. Its name is propane. And we have a methyl group, CH3, located at carbon number 2. So the name of this compound is 2-methylpropane. Both compounds are called isomers since both have the same molecular formula, which is C4H10, but different structural formula. Here it's a straight chain alkane, here it's a branched chain alkane. So both compounds are isomers. They are two different compounds. Let's take another example about isomers, which is C6H14. You can represent it as a straight chain alkane, unbranched alkane, where its name is hexane, since we have 6 carbon atoms in this chain. The second way, you can represent it as a branched chain alkane by removing the terminal carbon atom, and you can attach it to the one of the internal carbon atoms. So you will get a branched chain alkane. Let's give the name of this branched alkane. The main chain is made up from 5 carbon atoms. And here we have a methyl group, a branch located at carbon number 3. So the name of this alkane is a 3-methylpentane. You can draw another isomer by locating 2 branches on the main chain. So you can remove this terminal carbon atom and you can attach it to the internal carbon atom here. Let's give the name of this molecule. The main chain is made up from 4 carbon atoms, where we have 2 branches. The first branch is located at carbon number 2 and the second branch is located at carbon number 3. So the name is 2,3-dimethyl. Why dimethyl? Since we have 2 methyl groups. So 2,3-dimethyl butane, since the main chain is made up from 4 carbon atoms. Now let's move to the second objective, which is about the physical properties of alkanes. The first property is that alkanes are in general colorless and odorless. The second property is about the physical states of the first 4 alkanes. The first 4 alkanes, which means from n=1 till n=4. So I'm talking about methane, ethane, propane, and butane. They exist in the gaseous state at room temperature, while the other unbranched alkanes from n=5 till n=17, they exist in the liquid state at room temperature, and the other alkanes for n is greater than 17, it's 18 or more, they exist in the solid state. Now let's talk about the boiling and melting point of an alkane, of a straight chain alkane. As the number of the carbon atoms increase, the boiling and melting point increase. While if you have to compare the boiling point of a straight chain alkane and it's a branched isomer, so the boiling point of an unbranched alkane, a straight chain alkane, is higher than that of its branched isomer. In the last property, alkanes are insoluble in water, can't be dissolved in water. Since they are nonpolar compounds, they can be dissolved in organic solvents. They are soluble in organic solvents such as benzene and chloroform.